Hello everyone, welcome back. In this video, we are going to continue questions 4 to 6 of exercise 6.2 of lines and angles. We have already completed 1 to 3 questions of this exercise and I have shared the link in the description. You can check out that video also. Now let's get started. So question number 4, it's given in figure. So this figure is given here. PQ is parallel to ST. This PQ, it is parallel to ST. And angle PQR is equals to 110 and angle RST is equals to 130 degree. Find angle QRS. So angle QRS we have to find, QRS. So this angle we have to find. So here we have to do one construction. So we'll draw one line which will pass through point R. So let's name this line as AB. We have to draw or we have to construct this line in such a way that this line, it's parallel to PQ also and it is parallel to ST also. So let's proceed the same way like we are doing. First of all, let's write the given things. So it's given PQ is parallel to ST and then the values of two angles PQR and RST is given to us. We can mention those values also. Then to find, we have to find angle QRS. Then here we have done construction also. So we can mention this point, construction. So AB, we have drawn one line through point R. See this AB, it's passing through point R such that AB is parallel to PQ and AB is parallel to ST also. Because PQ and ST, they are already parallel to each other. So if this is parallel to this, it's understood that AB will be parallel to ST. So we have to mention like this, AB is parallel to PQ and it is parallel to ST. Now solution. So here, first of all, let's take these two lines, ST and AB. So ST, it is parallel to AB. So reason we can mention by construction. Because by construction this AB is parallel to ST. So everything or every reason it should be mentioned properly. Now we can see this angle RST which is equal to 130 degree and this angle SRB. Both of these angles are making a pair of alternate co-interior angles. You can see these are on the inner side of the parallel lines plus on the same side of the transversal. If SR is a transversal, then this angle and this angle, they are on the right side of the transversal. So these two angles, they are making a pair of co-interior angles or consecutive interior angles. So let's write it down. Since ST is parallel to AB, therefore angle RST and angle SRB, they are co-interior angles. And we know co-interior angles are supplementary to each other, which means their sum is equal to 180 degree. So we can mention RST plus angle SRB is equal to 180 degree. Because co-interior angles are supplementary angles. So RST, its value is 130 degree. It's already given to us. We can substitute the value. Then SRB is equals to 180 degree. Now angle SRB Since we need to find the value of this angle, so we'll shift 130 to other side. So plus 130 on changing the side will be changed to minus 130. So 180 minus 130 is equal to 50 degree. So we got the value of this angle equal to 50 degree, angle SRB, which I have marked with red color. Now, so this is about this pair ST and AB when these two lines are parallel to each other. Now let's take PQ and AB, because we know by construction this AB, it's parallel to PQ also. So let's take those two lines now. So PQ is parallel to AB. Same reason we can mention by construction. How these are parallel? Because this is not given to us. By construction we have drawn one line AB which is parallel to PQ and ST. So that's what we have mentioned here. Now since these two lines are parallel to each other, you can see if we extend this line, because this will be a straight line if it's parallel to this line. So then QR will be transversal in case of these two lines. So if we see this angle and this angle PQR and angle SQRB, not as these two angles, they are making a pair of alternate interior angles. I'll just draw here. So this is PQ, here point PQ. So this is transversal QR and this is AB. So I am talking about this angle PQR and QRB. See, these two angles are on the inner side of the parallel lines, plus they are on opposite sides of transversal. This angle, it's on left side of the transversal and this on the right side of the transversal. So due to which these two angles are making a pair of alternate interior angles. So let's write it down. Since PQ is parallel to AB, therefore angle PQR is equal to angle QRB. Why these angles are equal? Because these two angles are making a pair of alternate interior angles, and alternate interior angles are equal to each other. So we can mention the reason. Angle PQR is equals to QRB because of alternate interior angles. Now we know the value of PQR, which is already given to us 110. So instead of writing PQR, let's write it down, its value, angle 110 is equals to QRB. So we got the value of angle QRB. So this angle, if we see in the figure, this one. So we got QRB is equals to 110. But here if we see angle QRB, it's a sum of two angles. This angle which is QRS plus this angle which is SRB. So let's write it down, angle QRB, it is equal to, see this complete angle QRB, this is equal to sum of angle QRS plus angle SRB. This concept from first exercise we are using when this complete angle, it's a sum of these two angles. So QRS and SRB. So I have just broken down QRB as angle QRS plus SRB. So QRB, we know its value, which is 110. So let's substitute its value over here. So here we can write proved above also, or then QRS, this we don't have, plus SRB. See this, we have already found this value equal to 50 degree. Now we need to find the value of QRS. So let's keep QRS on one side and shift all the other angles on other sides. QRS, let's write on this side. Say QRS plus 50. 50 will shift to other side. This is plus 50. On changing the side, it will be changed to minus 50 is equals to angle QRS. So 110 minus 50 is equals to 60 degree equals to angle QRS. So angle QRS, which was our requirement, we had to find angle QRS, it is equal to 60 degree. So we have found the value. Now let's do the next question. In question number 5th, this figure is given to us and it's mentioned if AB is parallel to CD. This line AB, it is parallel to CD, and angle APQ it's equal to 50 degree, and angle PRD it is equal to 127 degree. We have to find the value of X and Y, this and this. So these two angles we have to find. Now here let's start. We have to start the same way like we are doing. First of all, write the given things. So in given we can mention AB is parallel to CD, APQ is equals to 50 and angle PRD is equals to 127. So these things we can mention in given, and then next point is to find. To find we have to write X and Y. Now let's do the solution. So here now we know AB is parallel to CD. We can write AB is parallel to CD. This is already given to us. See, when AB is parallel to CD, here I will draw one line. We can see PQ is a transversal. So this is PQ. Now this angle is given to us 50 degree and this angle is X. So if we see these two angles APQ and PQD, which is equal to X, these two angles, they are forming a pair of alternate interior angles. They are on the inner side of the parallel line and opposite sides of the transversal. So we know alternate interior angles, they are equal to each other. So we can mention, since AB is parallel to CD, therefore, and PQ is a transversal in this case, you can also mention this. Therefore, angle APQ, it is equal to angle PQD. See, PQD, this one, PQD, angle PQD. Reason we can mention alternate interior angles. These two angles, they are forming a pair of alternate interior angles, and alternate interior angles are equal to each other. Now we know the value of APQ. So we can substitute its value because this value is already given to us. APQ is equals to 50 degree is equals to PQD. So we know the value of PQD also, it is X. So we can write here, instead of PQD, angle PQD, we can directly write X. So from here we got the value of X. X is equals to 50 degree. Now we have to find the value of Y. So let's move forward. So again we have to mention this thing. So one different figure I'll draw now. So same lines, because it's given AB is parallel to CD and same transversal. So instead of same transversal, now we will take this transversal PR. Earlier we took PQ, now we are taking this transversal PR. So only that much I am taking now, two lines AB and CD and transversal PR. Here this is one angle and this is one angle. So this angle is PRD, which is already given to us as 127 degree, and this angle APR, see APR, so which is a sum of two angles, which is 50 plus Y. But from this figure, if we see these two angles, they are forming a pair of alternate interior angles. Just observe this figure, you can see both of these angles, they are on the inner side of parallel lines and opposite sides of transversal PR. One is on left side of PR and other angle is on right side of PR. So these two angles also, they are forming a pair of alternate interior angles, and alternate interior angles are equal to each other, which means this angle is also equal to 127 degrees. So let's write it down. Now again we'll write AB is parallel to CD and PR is a transversal. We are not taking PQ. PQ we took in the previous case. Now PR transversal we are taking. PR is a transversal. So therefore angle APR is equal to angle PRD. So here we can mention the reason, alternate interior angles. Alternate interior angles, because we know alternate interior angles are equal to each other. So APR we can write as it is equal to PRD. So instead of PRD we can write its value as 127 degree. Now APR, let's see this figure. APR is this complete angle. See, from here we are starting and this one. So again same thing we have to use. We have to split APR into its two angles. One is APQ and the other one is QPR. So here also if I do, this is point Q. So this angle plus this angle. So instead of APR, now let's split it into its angles. So one is angle APQ plus angle QPR is equals to 127 degrees. So here we can mention the reason also, because angle APR, it is equal to angle ARQ plus angle QPR. So we can erase this figure, it's not required now. See, we have been using this concept from the previous exercise itself. One complete angle we are breaking down into its two constituent angles. See, one is APQ, this one, and the other one is this one, which is QPR. So complete angle APR is the sum of this angle plus this angle. So if we add, we will get this. So ARQ, it's APQ, sorry. APQ. So APQ, we know its value, it's equal to 50 degree. I have already written here APQ plus angle QPR. QPR we don't have the value, is equals to 127 degree. Now we need to find the value of angle QPR. Let's keep QPR on one side and shift 50 on other side. So plus 50 on changing the side will be changed to minus 50. So therefore angle QPR is equal to 127 minus 50 degree. So which is equal to 77 degree. So we got the value of, and we know from here itself we can see QPR, it is equal to Y. So instead of QPR, let's write it down as Y. From here also we can write it down, because we know angle QPR is equals to Y. So we got the value of Y is equal to 77. So X is equal to 50 and Y is equal to 77. Now let's do the next question. So in this question, this figure is given to us and it's given PQ and RS are two mirrors placed parallel to each other. So this is PQ and RS. These are two mirrors which are placed parallel to each other. So an incident ray strikes the mirror PQ at, so this is incident ray, it is striking this mirror PQ at point B, and then the refracted ray, it moves along the path BC. So this is the reflected ray which moves along this path BC. Then again it strikes this mirror RS at point C, and then again it reflects back along this path CD. So we have to prove that AB is parallel to CD. So what is given to us, that these two are the mirrors which are placed placed parallel to each other, and then this is incident ray and which gets reflected along path BC, and then again this ray, it is getting reflected along path CD. So this thing is given to us and we have to prove that AB, it is parallel to CD. So in given we can mention, we'll take these two mirrors as these two parallel lines. So we can write PQ, it is parallel to RS. So BC, here we will take BC as a transversal for these two lines. Now we have to prove that AB, it is parallel to CD. This AB, it is parallel to CD. So here we have to do construction also. So let's do the construction part first. So we'll draw two parallel lines or two perpendiculars. First one, this straight line, and here also one straight line we have to draw. Let's name it as point number E, this as point number F. And here we can name this as angle 1, this as angle 2, angle 3 and angle 4. See, two straight lines or parallel lines BE and CF we have drawn, and this line, it is perpendicular. Perpendicular means this line BE, it's making an angle of 90 degree with PQ, and CF, it's making an angle of 90 degree with RS. So straight perpendiculars we are drawing. So in construction we can write, because whenever we are doing any construction we have to add this point also. So we can mention BE perpendicular to PQ and CF perpendicular to RS, such that BE, it is parallel to CF. See, because both of these lines, they are making an angle of 90 degree. So 90 degree means completely straight, which means these two lines are parallel to each other. So this thing we have to do, and we can mention this thing in construction. Now let's start with the proof. Since we are talking about incident ray and reflected ray, so here we have to apply one concept of laws of reflection. In physics we have already done it, that angle of reflection is equal to angle of incidence is equal to angle of reflection. So here if we see, this is one straight line perpendicular or normal we can see, and this angle which line AB or incident ray is making with this perpendicular, this angle is angle of incidence, and this angle which we have named as angle 2, and this refracted ray is making with the perpendicular line. So this is angle of reflection. So according to laws of reflection, angle of incidence is equal to angle of reflection. According to laws of reflection, we can mention angle 1 is equals to angle 2. Angle of incidence is equal to angle of reflection. This thing you have to mention here, due to which angle 1 is equal to angle 2. So with this perpendicular line they have to make an angle. This is incident ray, this angle is with perpendicular line, and it is between incident ray and perpendicular line, and angle 2, it is between this perpendicular and between reflected ray. Same way, now this ray is striking here, which means for this mirror BC is incident ray. Again we'll apply the same concept, same law, that angle 3 is equal to angle 4. Since this is perpendicular now or normal, So here the angle between incident ray and this normal, it is angle 3, and the angle between reflected ray and normal, this is angle 4. So this is angle of incidence and this is angle of reflection. So we can mention, therefore angle 3 is also equal to angle 4. Same, angle of incidence is equal to angle of reflection. So we can name these two as, this is as point number 1 and this as point number 2. So from here we come to know that angle 1 is equal to angle 2 and angle 3 is equal to angle 4. Now this we were taking these two parallel lines, PQ and RS. So we can mention also PQ parallel to RS. Here we can add this step. Now we will take these two lines when BE is parallel to CF. BE is parallel to CF. Here I will draw, this is line BE and this line is parallel to CF, and this is the transversal BC. So here when BE is parallel to CF, we have already done it by construction, and BC is a transversal and BC is a transversal. In this case, this angle and this angle, see angle EBC and angle BCF, these two angles, they are making a pair of alternate interior angles. See, they are on the inner side of the parallel lines and opposite sides of the transversal. This angle is on this side and the other one on the other side of the transversal. That's why these two angles, they are making a pair of alternate interior angles. And from here, if you compare this with this, you can see this is angle 2 and this is angle 3. See, angle 2 and angle 3, these two angles, they are forming a pair of alternate interior angles. So we can mention angle 2 is equals to angle 3 because of alternate interior angles, and we know alternate interior angles are equal to each other. Now we have to prove that AB is parallel to CD. So this is also, we know that angle 1 is equal to angle 2 and angle 3 is equal to angle 4. This thing we already know. So here what we'll do, here we'll just multiply this equation with 2, both the sides. We can mention also multiply both sides with 2. So on multiplying, you can write 2 into angle 2 and 2 into angle 3. So after multiplication, 2 into angle 2 means 2 times angle 2. So 2 times angle A, I will write it as angle 2 plus angle 2 is equal to 2 times angle 3 means angle 3 plus angle 3. See, angle 2 plus angle 2, it will be equal to 2 times of angle 2, and angle 3 plus angle 3, it is equal to 2 times of angle 3. I have just multiplied both the sides with both the sides with 2, because whenever we make any changes in the equation, we have to make that change in both sides of the equation, so that, see, this and this will get cancelled. So at the end I have angle 2 and angle 3, both are equal to each other. So whenever we make any change on both the sides of the equation, it doesn't make any change. So that's why we have multiplied both the sides with 2. Now we got 2 plus 2 and 3 plus 2, and we know that angle 1 is equal to angle 2. So just replace angle 2 with angle 1 and angle 1 plus angle 2, and here we know angle 3 is equal to angle 4. So replace one angle 3 with angle 4. So here we can mention also from 1 and 2. Because we have already named these 2 points as 1 and 2, you can write here from 1 and 2. See, I had angle 2 plus 2. So in place of this angle 2, I have just written angle 1, because angle 1 is equal to angle 2. So angle 1 plus this angle 2 I have written as it is, and same here angle 3 plus angle 4. So this 3 I have written as it is, and this instead of angle 3 I have written angle 4 because angle 3 is equal to angle 4. Now from here I got angle 1 plus angle 2 is equals to angle 3 plus angle 4. If you see 1 plus 2, it is this angle complete, which is A, B, C, and angle 3 plus 4, which is this complete angle B, C, D, angle B, C, D. Now if I erase everything else, just see here, these two angles, this one and this one, these two, they are making a pair of alternate interior angles, and we know if a pair of alternate interior angles is equal, then these two lines are parallel to each other. We have already done the proof of theorem also. So now if these two angles are equal, we can mention the reason. If two lines, they are intersected by a transversal such that the pair of alternate interior angles are equal, then these two lines are parallel to each other. So I'll write the reason also. If two lines are intersected by a transversal such that pair of alternate interior angles is equal, then these two lines are parallel to each other. So these two angles, they are making a pair of alternate interior angles and they are equal to each other also, due to which we can mention therefore AB is parallel to CD. So this full theorem you have to write as a reason due to which AB is parallel to CD. So this is what we had to prove. So with this, exercise 6.2 is completed, and I'll continue with exercise 6.3 in my next video. Thank you so much for watching the video. See you in my next one.